Okay, so today we are going through 2E. And Harry, you know what? This is going to be a really good exercise because again it's a point of consolidation where we're bringing everything we've done together, and all of the questions I've written in our notebook they're written, okay? And what we're going to do is we're going to take these words, we're going to draw a picture of it, a picture of the graph that satisfies these requirements, these contingencies, and from that we can think about what's the equation that's going to follow suit. So, to start with, let's sketch it. We've got a quadratic that cuts the x-axis at 3 and minus 2. So that's where it passes through the x-axis, and then it passes through this point. So I'm going to just do a really rough sketch, okay? So here's my Cartesian plane. X is minus 2, x is positive 3. They're going to be there. And it passes through the point when x is 2, y is minus 4. So across 2, down 4, it's going to be somewhere there, right? That's the point. X is 2, y is minus 4. So it has to go through these 3 points. And because it's a parabola, the only possible shape it can have is something like this, right? It has to look something like that. Remove the minus 2. Okay, so we've got an idea of what this graph looks like. And now we're just doing what we did in 2D. We've got a graph and we know the roots, all right? Remember, what are the forms we have for a quadratic? We have linear factors and we have completed square. Okay, these are both listed on the back on the summary page. Linear factors is beautiful because all we have to do is take the roots and put those numbers where P and Q are. All right, so my roots here are minus 2 and positive 3. So when I put it into the equation, it's going to be y equals A. We always put A out the front because that's the dilation factor. We need to determine if it's 1 or not. We always put A out the front. And I've got x take P. Okay, what's my first root? Minus 2. So I'm going to have x take minus 2. And then multiplied by x take Q. What's my second root? Positive 3. So x take away 3. And I'm just going to simplify it. So take minus becomes positive. Alright, remember, what are the roots? The roots are the values that make it equal to 0. You can see minus 2 would make the whole thing equal to 0. Positive 3 would make the whole thing equal to 0. Okay, so we're set up for the basics of it, but we need to determine this value of A. And so we need to use another piece of information. We've used this root, we've used that root. What other information are we told? This point here, which tells us when x is 2, y is minus 4. And so we're going to sub that in. We're going to put minus 4 where the y is and positive 2 where the x is. All right, so I'm just going to restate what I've got up here, except I'm putting minus 4 where the y is and positive 2 where the x is. And then it's just a matter of simplifying, right? 2 plus 2 is 4. 2 take 3 is minus 1. So then A times 4 times minus 1 is minus 4A. And so the only value of A that makes this true is 1. A equals 1. Okay, so our quadratic then has this equation. It is we don't need to write the 1 though, alright? I'm just putting it there to show you that's where the A value goes, so I'm going to rub it out now. And let's just read the question carefully. It says, write the equation in the form ax squared plus bx plus c. So they want us to write it in general form. So we've started with general form, and if we factorize it, we can get the roots. And if we complete the square, we can get the vertex. Now we're starting with a quadratic that's expressed in linear factor form, and we want to go back to general form. All we have to do is expand this, okay? FOIL. Each term inside needs to multiply each term on the outside. So we're going, maybe a good time to recap FOIL, okay? FOIL is how we multiply two brackets. F stands for the first terms, all right? So I'm going to multiply x by x. They're the first terms in both of the brackets, right? X times x, that's going to give me x squared. Okay? O stands for outside terms. So the outside terms are the one on the far left and the one on the far right. You see how they're the ones on the outside of the product. So I'm going to multiply x by minus 3. That's going to give me minus 3x. I is for inside terms. So they're the ones that are next to each other. So we're going to do 2 times x. That's going to give me plus 2x. And then L is for the last terms. So I'm going to multiply 2 by minus 3. That's going to give me minus 6. Okay, and then we just collect like terms. X squared minus 3x plus 2x is minus x. Take 6. So you can remember FOIL, you can apply FOIL, or this first term needs to multiply both of them. The second term needs to multiply both of them, and then collect like terms. Okay? Hopefully pretty comfortable with that. If it's a skill you need to practice, let me know. I'll provide some extra resources. Now, this is general form, right? We've answered it the way it wants us to. ax squared plus bx plus c. All right, so we moved from linear factors back to general form. All right, by doing the expansion. How do we move from general form to linear factors? By factorising, okay? By factorising using the cross method. All right, so that's part A. We were just asked to find the equation of the quadratic in general form. Done. Let's have a look at part B. I won't go about the whole thing, I'll leave a bit of that if you need it. So we've got touches at 3. Passes through 1, 8. Touches the x-axis at 3. Alright, so if I'm going to sketch that, it touches it. That means it doesn't cut it. That means it has to be a double root. Touches at 3. 1, 2, 3. It has to be here. X is 3. That's where it touches. So the vertex is touching, and it passes through the point. X is 1, y is 8. So x is 1, y is 8. That's going to be here somewhere. So the only way a parabola can satisfy this is like this. Okay, touching at that point. The reason it can't have roots is because if I go through, it has to come back up, and then it's cutting it twice. It doesn't cut it, it touches at that point. And so here we have the coordinates of the vertex, right? I'll pass through this point, 1, 8. The vertex is here. What's the coordinates of this point? I've got the x value.
3, 0.
0. The y value is 0 as well, right? It's touching there. I'm going to sketch it a bit better. There we go. It's touching at x is 3, y is 0. Excellent. And so we've done linear factors. Here, completed square form. H is the x coordinate of the vertex. K is the y coordinate of the vertex, right? So these coordinates here are H and K. So now we can go from there to completed square form. Y equals A times X. I'll write out the form and then I'll perform the substitution. Completed square. Why are we using completed square? Because we have a vertex. We're not given the roots, we're given the vertex. So I'm putting H there and I'm going to put K there. So it is x take 3 squared plus 0. All right, plus 0, we don't need to write that, okay? We can just eliminate that component of it. Now, we need to use another piece of information to determine this value of A, right? Well, we're told this one, all right? We've already used the vertex, so we can't use the same piece of information again. It's not going to help us. Instead, we're going to use this one. We've got x is 1, y is 8. So we'll make that statement. When x is 1, y equals 8. And all I'm going to do now is put 8 where the y is and 1 where the x is. Okay, let's evaluate that. So 1 take 3 is minus 2, and minus 2 squared is positive 4. So we have 8 equals 4a, divide both sides by 4, a equals 2. The value of a that makes this statement true is 2. Alright, so then our quadratic in completed square form is this one, y equals 2 times x take 3 squared. But this isn't general form, and it says answer in the form ax squared plus bx plus c. So we need to expand it. Now here you've got two options, okay? You can do perfect square, and I encourage you to be comfortable and competent in doing that. If you're not sure, you can treat it as FOIL, right? And you can just focus on this part and go, yep, x times x times minus 3 times x minus 3 times minus 3. Okay, so you can do a FOIL there as well. Nonetheless, I'm going to do perfect square expansion, and it's a good opportunity for me to remind you of BEDMAS as well, like the order in which we would perform these operations. Okay, so BEDMAS says you start with any operations in brackets. So we would do x take 3. We can't evaluate that. X is our variable, right? 3 is a number. So brackets are done. Next, we would move on to exponents. So that means first you need to square it and then multiply the 2 through. Okay? Brackets, exponents come next. All right? So x take 3 squared. I'm going to evaluate this using the perfect square rule. All right, x squared take 6x plus 9. A squared take 2ab plus b squared. All right, if it's a skill you want to practice, let me know. I can provide lots of resources. Localize the areas you need to work on, right? So, can't do anything in brackets. We perform the exponents. Now, division and multiplication are actually the same operation, all right? I won't say any more on that, but what comes next is no division, so we've got multiplication. We're distributing this 2 into the bracket. So it's going to expand to 2x squared take 12x plus 18. Now we've answered the question. We've stated it in the form ax squared plus bx plus c. All right, let's move on to C. Now C is a good one. I like C. So we've got cuts the x-axis in 1 and has a vertex at minus 3, minus 8. All right, so cuts here, vertex here. That's x is 1, vertex minus 3, minus 8. All right, so we've got those 2 points. The only possible way the quadratic can pass through these points is like this, right? There's the vertex, that's the turning point, okay? And here's the other root. Now, the beauty of this question is there's actually 2 ways for us to go ahead and solve it. And I'm going to show you both to really emphasize a cool connection here. The first one is just using the completed square form, right? We've got h, we've got k, and so we know a completed square is x take h squared plus k. We've got h is minus 3, and we've got k is minus 8. Okay, so we can recognize the vertex. Yep, there we are. And then use this coordinate. Although we're only given one piece of information. We're just told x is 1. What's the y value? 0. X is 1, y is 0. They're the coordinates of those points. If it cuts the x-axis, y has to be 0. So you make that statement. When x is 1, y is 0. Okay, let's plug that in. So we're going to have 0 where the y is, 1 where the x is. One plus 3 is 4. 4 squared is 16. Alright, so I've hammered ahead there. I'll pause for a second and let you sort of jot it down. So all I did, we sub x is 1, y is 0 in. Here I've added 8 to both sides. So I've got 8 is equal to 16a, and the only value of a that makes that true is positive half. I've divided both sides by 16. 8 divided by 16 is the same as 1 or 2. Okay, so that's using the completed square method, right? What do? We started with the vertex, we put it in vertex form, and then we used this other piece of information. Okay, done. And then we can expand it. All right. Let's talk about the other process. Let's make a connection here. So we know this root is 1, and we know this is the vertex minus 3. And we know that's the middle. All right. That's the axis of symmetry. That this root and this root are equally spaced apart. So if this distance is from minus 3 to positive 1, this has a distance of 4, then so does this. And so that means this root has to be minus 3 take 4, negative 7. All right, and so we can get the roots because we know the x coordinate of the vertex, right? We can get the roots, and so we could write this one out like this. X take 1 and x take minus 7. All right, if you can identify the roots, we can put it back in linear factor form and use the linear factor form. All right, so that's the connection I wanted to make. Okay, let's answer the problem though, because here's what we've got so far. If I jump back to here, we've got x plus 3 squared take 8. Maybe, can I stop before we go to that? Does anyone have any questions, Harry, about these linear factors, or can everyone see the relationship there? Okay, it's the middle, so 4 units there, 4 units there. Yep, Stella looks good. Yep, Amber, yep. Harry? Cool, excellent, all right. So let's, I'm not going to repeat the whole thing again because, you know, I'm just pointing out that's one way of answering this problem. So here we've got what we had down here, right? We had x take 8 squared, x plus 3 squared take 8, and we've got this a up front. So we are asked to write it in general form. That's what it says at the top, ax squared plus bx plus c. So, bed mass, right? First the brackets, can't do that. Next the exponent, so we need to square it first. Okay, we need to square it first. So I'm going to use the perfect square rule, x squared plus 6x plus 9, this one. And we have this take 8 hanging out. Next, division and multiplication. All right, so I'm not going to put this minus 8 in there because we're required to multiply it first. That's what those brackets tell us, right? Half times everything. So I'm going to distribute the half. Half of 9, you can write 4.5. Or you can write 9 on 2. 9 on 2 fraction, half of 9. I reckon let's put 4.5, because it's going to make more sense for you in a moment when we just subtract 8. Okay, so we did brackets, exponents, multiplication, division and multiplication, now addition and subtraction. What can we add along here? Well, the only like terms are these last ones. 4.5 take 8. Minus 3.5. Okay, so we've answered it in general form. We've got the A value, B value, and the C value. Very good. Okay. Last one. And the last one here, we have to use the connection we made before. So this is D. We've got cut at x is 2, passes through, x is 1 and 4. And it has axis of symmetry, x equals 3.5. Alright, so the axis of symmetry is this line here. Alright, so the only way a parabola can satisfy this is like this, right? We're told the x coordinate of the vertex, the axis of symmetry, x is 3.5. And so here we have to use the roots, alright? So what's the distance from 2 to 3.5? That's 1.5. So that means it has to be symmetric about that point, that axis of symmetry. Alright, so we're going 1.5 points in that direction as well. So if we're going plus 1.5 plus 1, we're moving up 3 units in total, right? And 2 plus 3, that's going to take you to positive 5. So we've got the roots, alright? So this time we're not using the vertex, we're using the roots. A times x take p times x take q. What are our roots? Positive 2, positive 5. Now we need to use another piece of information, right? So we've already used that root, We're not told enough here, we're only told an x value. We don't know the y value of that point, so we can't use that here. We need to use this one. When x is 1, y is 4. Alright, so 4 where the y is, and 1 where the x is. Okay, so we determined the value of A is 1, and so then I'm just restating the equation of the quadratic here. And we're asked to answer it in general form, so some FOIL. Alright, so hopefully we're really starting to see the relationship between these 3 forms, right? Okay, any questions? Alright, so 3E, let's get into it.